Yeah, I want to start many years ago when I was a kid, and I saw a movie that is called Apollo 13. So this is a classic Hollywood movie about the space mission that was intended to land on the moon. And I actually think that some of you or many of you probably have also seen it. Let's check. Who has seen this movie, Apollo 13, I mean? A few people. All right, good. You don't have to know the plot of that movie, but you probably know the most famous phrase from that movie that sounds like, Houston, we have a problem. So this phrase became a kind of iconic, and we use it in some ironic context to describe some unexpected problem. And this phrase was actually said by the mission commander during the mission, but I believe during that time he was like 0% ironic. He was non-ironic as possible. And that's why. Imagine a spaceship that was already approaching to the moon when something happened with the wires, and as a result, an oxygen tank exploded. Like this, boom. Oh yeah, if we consider that there are no sound waves in space, it was like just... Alright. Then the mission was failed, and now the only objective that has left was just to return the astronauts home alive. And the spacecraft consisted of two modules. One was the main one, which was called Odyssey, and it was supposed to contain the astronauts during the whole flight. And there was also the second module, the lunar one, that should have been used to just land on the moon and to get back. So now the main module started to rapidly lose oxygen, and the crew, to survive, had to move to the lunar module, which wasn't designed to supply them with oxygen for a long time. So now they needed to come up with some idea. And luckily, both modules had carbon dioxide filters. So the filters from the main module were big and rectangular. And the filters from the lunar module were small and round. And the filters from the main module could last much longer than the filters from the lunar. So now they had to think how to fit those big rectangular filters into the round holes of the lunar module to survive. And actually, the guys in the command center, they were experimenting on Earth, and they created some instructions. It consisted of 12 steps, and it included actually the filter itself, a plastic bag, a piece of a towel, some other items, and of course some duct tape. So in the end, the result wasn't fancy, wasn't elegant, but it worked. This is a replica actually. And the astronauts were safe. They managed to successfully return to Earth, which was a huge success given the circumstances. And, well, what did I learn from that movie? I don't remember actually, because I was like 9 years old, and probably I thought something like, wow, spaceships are cool, or space is a dangerous place, but I certainly didn't question whether they did the right thing, because when it's a matter of life and death, it doesn't matter how beautiful the solution. If it works, that's good. So today, oh, sorry, a different slide. So now, fast forward to the time when I was starting my career as a junior developer. I wanted to become a good professional, so I immersed myself in some classical literature like clean code, refactoring, design patterns, and all these books, they painted a picture of an industry that was governed by some well-established practices, and even if like developers produce sometimes they produce bad code, or as nowadays we call it suboptimal code. We don't use bad anymore. So if they produce suboptimal code, that happens because of strict deadlines maybe, or a lack of expertise. But if you have enough knowledge and enough time, you probably have a clean, shiny, and elegant code. And yes, I was wrong. So today I'm going to share with you 3 stories. First one is about a competition between some sophisticated search algorithm and a straightforward solution. The second one is about rethinking architecture, and the third one is about some performance improvement that was technically was great, but the results were disappointing. And after all, I would like you to share your stories. All right. When I started here in Devexperts many years ago already, I faced a task. I needed to adjust a search algorithm, and I needed to make it more flexible, I would say. So our trading platform contained a lot of different financial securities, and each one has its own human readable description. So there was an ability to search through those descriptions. So if you, for example, wanted to buy some Apple stocks, you didn't need to know the exact ticker name, which is AAPL. You can just enter Apple and you will see some relevant results. The matching in this search algorithm was strict, so it returned exactly the results that contained this exact substring. But it worked fine because, well, the descriptions were pretty short usually. And the challenge arose when we introduced some indexes that had some verbose descriptions, like this. Harmonized index of consumer prices, tobacco for friends. This one is the shortest one, actually. You see that the other ones are really longer. So our customers wanted us to support some flexible search. So if a user enters something like index tobacco friends, they would see some results independently of these words, how these words are positioned in this description. So when I started working on this task, I quickly realized that the algorithm itself was based on some dissertation from Tokyo University. The dissertation was like 120 pages long, and the algorithm itself was pretty complicated, pretty complex. So I spent a lot of time digging into it, and I was thinking about it at work, at home, and commuting from work to home and back. And in the end, after a week or so, I had some solution. So the algorithm, which wasn't simple before my change, it became even more complex. But I was happy and proud of myself because I made it work. And I think that I hadn't sent this task to review yet when I shared this story with my colleague during some casual chat near the coffee machine. And that guy, instead of just admiring how extremely extraordinary smart I was, he said, "Did you just try using string contains and checking all the strings with it?" And I said, "No, why would I? That will be probably much slower." So his idea was straightforward. This is a simplification, but just to get an idea. So let's just split the user input from our client to tokens, and let's check every description if a description has every token that the user entered. So this was a pretty brute force-ish approach, and actually my colleague implemented it, and there was a question still how effective it was. So we created some kind of a performance test using some sample data, and then the results were surprising because his algorithm was only 3.5 times slower than mine, which in absolute difference was like 7 milliseconds. So like no human being would be able to spot it. And it was a hard pill to swallow for me because everything that I had done wasn't worth it. But it was clear that we should go with his approach because it's more maintainable. I think it taught me that the simplest way is sometimes, yeah, it's the most effective one. And yeah, at this point, I would like to ask you if you recall anything like that. So if you do, please keep it in mind, and we will return to it later, and we will have some prizes for it. So my second story is about some architectural changes. You know, I've been conducting a lot of technical interviews, and during the last 2 years, I usually start with presenting our project to the candidate, and one of the most popular questions from the candidate's side, well, actually, can you guess which one is the most popular? It's not related to the domain or something. Any guesses? What's that?
Why is it monolith instead of microservices?
You're close, actually. They usually ask, do you have microservices? Because we have like a mixed approach, we have both. So, yeah. Actually, sometimes candidates are not even interested in what we develop and how we do it, but they need microservices. So there has been a big hype about microservices, it still is, and I'd like to tell you a story that comes from a friend of mine working in a startup. So imagine an audio service that allows musicians from different parts of the world record some tracks simultaneously, playing some instruments or singing, and then to combine them into some final composition. So a part of its logic looked like this. So the service receives some raw audio, it splits it into some chunks, it detects some defects in the chunks, so it may be some delays or maybe some missing fragments, and then it tries to restore the data, and in the end, this service got the corrected audio. So the team decided to implement this service exactly like that, utilizing the microservices approach. And they got something like this. So they had a splitter, a defect detector, and restorer. Each one did its own job and stored some intermediate results into some storage. It soon became clear that this architecture didn't scale well. The audio processing itself was pretty fast, but the bottleneck was the time spent on these data storage operations. So the team was deliberating for a while, they discussed that, and they decided to go with a bold approach. They became monolithic. So now all the data transfers happened in memory, which significantly increased throughput, and also a good thing that their code was loosely coupled with the way the data was stored and transferred, so they didn't need to, to spend a lot of time reworking this architecture. I think this, the lesson here is that we not always should go with some popular approaches. We should choose wisely what works in our case. And my last story, and my favorite one actually, about some performance improvements in an online shop. So there was an online shop, not as big as eBay, but still facing some problems and challenges. The shop's engine was pretty old, and the loading time of one page could be up to 6 seconds. It's funny to say that after the previous talk about sub-microseconds operations, but yeah, it worked like that. At some point of time, the team decided to spend a couple of months to rework this engine, and they actually achieved some significant results. So they managed to drop this loading time by 5 or 6 times, and actually that was a huge success from the technical point of view. So they delivered this change to production, and everything worked well, but it wasn't the end of the story actually, because after a month or so, the business team noticed that the purchase conversion rate significantly dropped. So now, if a client opened a page of some product, they were less likely to buy it. There were no good hypotheses about why that could happen, but the only change was that performance improvement. And after a while, somebody suggested conducting an A/B test. So for one group of people, they didn't change anything. For another group of people, they added some artificial delay, so the page loading time was matching the loading time before the performance improvement. And surprisingly, the group with this artificial delay showed better conversion. After that, they had to conduct some customer interviews, and some of the customers told them that, well, they didn't trust the website if the page loads so quickly. So it felt like a scam for them. Yeah. So I must provide you with a disclaimer here, because it happened like 5 years ago, so probably it doesn't work like that anymore. don't take it too serious, like don't implement it in real life. We all want our pages to be loaded quickly nowadays. But still, the team had to leave some artificial delay. It wasn't that big like before the change, but yeah, they went forward with this artificial delay, and that significantly helped them with the conversion. So yeah, as this is a public talk, we must have some portion of wisdom in the end. And let's recap what lessons we can learn from these stories. So the first one suggests us that probably the simplest way sometimes is the best way to go, and also it's good to consult with your colleagues or your friends before tackling some problems. The second one suggests that we don't have to stick to some popular principles. We can choose the principles that match our needs. And the last one says that probably user perception is what matters, even if you have to do some technically bad things, but it helps users. Probably you should think about that. And also, if you have a good, even if you have a crazy hypothesis, but it's easy to test, why not? Give it a try. So, thank you for listening.